Right, so today we're going to look at more representations using power series. So I think one of these, if you've looked at the previous couple videos, should be pretty simple, the first one, right? So can you guys help me rearrange that into a suitable geometric series arrangement? So divide by 6. I think you're telling me this. Is that what you're telling me? Okay. So we have what, 8/6 or 4/3, 1 plus x squared over 6.
We have to write that as 1 minus.
And then we need to have this be minus a negative. This is the holy grail when you're trying to represent things as geometric series, or the convergence of a geometric series is that you need a 1 and you need a minus. Whatever everything else becomes, you just deal with it, right? You can use clever 1s, clever 0s, whatever, in order to get this 1 and this minus, because then this is the first term and this is the ratio. So this function can be represented by what? Series. We'll start with 0, go to infinity.
8/6.
8/6 or 4/3. Times negative x squared over 6 to the n power. This, of course, being a sub 1, and this, of course, being r. Okay, so we've got that guy. What is its radius of convergence? What's its interval of convergence? What about that stuff?
The square root of 0.
So though, remember, geometric series are convergent as long as you have this. You could also, of course, do a ratio test on that guy, which you guys told me I need to go like this, right? So that's really just this, because of the absolute value, which is just this. If you multiply both sides by 6, because you could do that if it's just one thing. So this is going to be 6 and 6.
Root 6.
There's our interval convergence, our radius being the square root of 6. Yes. Okay, good. So that one wasn't too bad. So I think we had to think a little bit harder with our tools that we've learned to attempt to approximate this. So how do I do it?
Take the derivative and make it into.
Either take a derivative or you take an integral. So I think you want to think about the thing first that you can represent similarly to how we did number 1. What is that thing? Then we'll worry about whether it's a derivative or an integral, okay? So first of all, this is the thing, right? That we associate with arctangent, I hope. That thing looks extremely familiar to this thing over here. So why don't we work with this thing and then we'll worry about how we get that thing from that thing, if that makes sense. All right? So, well, first of all, and the last problem, first of all, we started by thinking of it like that. This is almost ready, good to go. We just got to go like that, and we're good, right? I need anything else? Possible I made a mistake. I don't think so, though. That's it, right? So this guy is equal to the power series from 0 to infinity. First term is 1. Ratio is negative x squared to the n. Done. But of course, that's the way you represent this function, not this function. How are these two functions related? How do I take this thing, which I now know?
Take the integral.
If I take the integral, I think that's the way to go on this problem. Because if I take the integral of this thing right here, I get what? I get arctangent. So do you see how first in my thought process, you don't have to do it like me, but I don't know, this is what makes sense to me. I'm like, well, I want to represent that function. I know something similar that's kind of geometric-y, which is this thing. I worry about figuring out that thing as a power series first, and then I think about how that thing relates to the thing I actually wanted to represent. I don't know if that chain of logic makes sense to you, but it makes sense to me a lot more than like, I just looked these problems up in another textbook and they were doing like, then this line becomes this line and this line becomes like, what? No one thinks like this. Come on, textbook. So, I don't know. So hopefully that's helpful. So what do I need to do with this power series then? Because this blue thing is that black thing, at least on whatever interval that we're thinking about here. So I need to put this integral here as well. Yeah, so they're the same thing?
With respect to x or n?
Good question. With respect to x or n, great question.
X.
How do you get from here to here? Very good question. Because there might be times where you'd integrate with respect to n. I think we might even do some Fourier series. I found in another textbook if we have time this year. So that might be a little different. Let's see. But for this one, the blue is the black. So how do I integrate this guy? Help me out.
First you're going to want to take out the alternator.
I like what Katie said. Okay.
And then you can do x to 2n.
And then we've got this integral in front. So with respect to x, like Kyle pointed out for us so kindly, so we're going to go, don't touch this thing because it's all about n's, right? It's really just a constant in respect to x, right? So don't even worry about the sum yet. Then we've got to integrate, the only thing that has x in it is here, the alternator doesn't get affected, so I think that was smart to break it up like that. What's the integral of x to the 2n?
X to the 2n minus 1.
Plus 2.
Plus 1, sorry.
2.
Or just plus 1.
Yeah, plus
Divided by
2n plus 2.
2n.
Now, I heard a couple people saying 2n plus 2, which I understand because you're thinking about like those other problems where we had to like think about plugging an n in there. This isn't that, it's just whatever. Remember, to integrate something that's an x to the power, I don't care if this is written as double or whatever, you just add 1. 1 is 1, done deal, okay? So that's the answer, except if you remember when we were working with integrating a differentiating power series, we really didn't do any problems till now. That's why I'm having us practice these. What do you have to be careful about when you integrate something? Plus c, because of course if you took the derivative, that c could disappear, right? So plus c has to be on this problem as well, and that's it, right? The only thing is you got to figure out c. Now when we're doing differential equations and stuff like that, we had like a point or an initial condition which told us c. You can do that with a power series as well. What's one place we know this converges for sure? 0. So why don't we plug in x equals 0 and find c that way? Does that make sense? Because ultimately, what's this equal to? What's this equal to on this side, guys? What's on this side the whole time? What we're trying to do. What were we trying to do? Trying to represent the inverse tangent. You guys need to shush. The inverse tangent of x. So let's plug in 0 throughout and solve for c. Does that make sense? So if I plug in 0 there, I have the inverse tangent of 0. If I plug in 0 here, I have the series. This becomes 0, so it's going to be 0 on top over number. And if it's just 0 plus 0 plus 0 plus 0, even wherever these indices are, do I even need that part? That's why we've used 0. C. Right? Plus c right there. What's the inverse tangent of 0? Think about your graph of arctangent. You could think about your graph of arctangent, this dude. That says this is 0. Or you could say, remember how you read this? Let's not forget our trigonometry. This says where does tangent have an angle of 0? And of course that's at 0 by thinking about the tangents graph or by thinking about some ratios. Okay. So 0 equals c, so this time we didn't have to worry about it, but in a lot of cases you would. And I know a couple of problems I gave you guys you need to worry about your c. Okay, so there's number 2. Let's do number 3 and we'll call it a day. So I think if you did that one, that should give you a hint, especially if you're watching the video on how to do number 3. So if you're lost on how to do number 2, I'd pause it and now try to do number 3, which is the same exact problem. Whoops. I have to juice it up a little bit. I just put some parentheses on there, guys. Come on, it can't be much harder. I meant to do that the first time.
It's like, well, now I have to redo mine now. Jeez.
Partial fractions is a good idea, but I think since that's
The
plus, it's not going to work. If it was minus, it'd be a great idea. This is kind of like what? Remember how we played the game for these other ones? Get them out of the way. This is kind of like this, right? And couldn't we do a power series for that geometrically? I think it was one of your problems actually, or one of the ones I did, somewhere in there.
So you're doing like a comparison?
And this is like that, right?
Yeah.
There's a derivative or an integral lurking in here somewhere. I don't know if I put the right helpful stuff on the board. How about this? Maybe this is more helpful. This is really close to that, isn't it?
You just do a
What
minus.
what would its derivative be? Just the same way that these guys have been doing stuff? Wouldn't you go... You don't even really need this one. What's the derivative of thing?
Oh. What a -2.
Oh, so that's
-1.
that.
Look at that and look at that.
Integrated.
So close to one another, right? So what was the key that I started off with? So why don't we figure out a power series for this? If we take the derivative of that power series, we will get almost exactly what we have. We'll just have like an extra negative we got to shove in there and we'll be good to go. If that makes sense, okay? So you can also do it with a derivative. So I need to turn this guy now. Let's remind ourselves. This guy is what we started with. What is the power series for this guy? I mean, it's pretty easy, right? You go
Negative x to the n. I pull out the alternator because that makes stuff easier.
I think that's smart. I like that. You don't have to, but you could do that, right? Okay, so
to the
that-
n, negative one.
Yeah. You guys are keeping me honest today. I like it. So that is that. But we said to get this to turn into that, we just took its derivatives. Now I'm going to take that and operate with the derivative with respect to x, not with respect to n. Okay? So I don't want to put an equals between this and this because they're no longer equal, right? This was thinking, now I'm taking a derivative, it's not equal anymore. So how do you take the derivative of that? Can you guys help me?
X to the n minus one.
N x n minus 1. That's pretty simple, our basic power rule. Okay? But remember, if you take the derivative of this, which is equal to this, it becomes this.
So you just slap an extra negative in there.
Couldn't you just do like n plus 1 on the negative one?
So we need, just using color coding for anybody who's not seeing it, it sounds like you guys are seeing it, but we need that to be multiplied here. So
You just put it
plus 1 or minus 1?
either.
It's true, it doesn't matter, but technically, algebraically, plus 1. Because there's another negative 1. Isn't there a negative 1 to the 1 power? You guys are right, though it really wouldn't matter because those are essentially the same in terms of alternation. Done. Don't have to worry about a c, it's a derivative, we're good. That's it. Okay, see you next time. Have fun with your power series representations.
Capybara.